we'll first continue with our functional dependency topic. I have uploaded the note, both functional dependency and the relational algebra. Okay, so if we have time, we will move into relational algebra also. So once we finish relational algebra, we have only two topics. Okay, that is SQL and the security part. Right, so we are halfway in functional dependency. So last time we discussed the Armstrong axioms. Okay, we discussed those things. Right. So now you must know what is mean by A function is determine B. So A function determines B means when you know A, you can uniquely say what is B. So that is what is mean by A functionally determine B. For example, if you know your BIT registration number, the university can definitely say what is your name is. Okay, what is your badge is. So that is functional dependency. But just because someone gives his first name, they can't tell exactly uniquely what is your badge, because there can be so many numerals, maybe semester 1, semester 2, etc. Even your full name is not good enough. There can be 2 or more people with the same full name. So functional dependency means we say that A function determines B. When we know A, we can uniquely say this is your B. Okay. Right. So you can see here, when you know A, right, you can definitely say it is B1, A2, B2, A3, B2, A4, B3. Right. So therefore A function determine B. But here A is not function determine B, because A1 determine map to both B1 and B2. So therefore we can't say whether it's B1 or B2. So therefore in that kind of a situation we can't say determine B. But clearly B determine A. Okay. So I hope you got it. So then we did some examples last time. So then we discussed the Armstrong axioms. So those are very interesting, and especially the first 3 are very important. Especially the first 2 are extremely important, and of course others are also very interesting. So the reflexivity means A determines A, or A functionally determines A. That is obvious, because when you know your student ID, you know your student ID. When you know your first name, when you know someone's first name, right? So we know his first name. So A determines A. Then the more interesting one, because it's a very obvious one, though it's obvious, so you have to appreciate it, you have to accept it, okay? Or you have to reject it by arguing. Of course, here I don't see any reason why you can reject this. So the second one is more interesting. If A determines B and B determines C, we can say that A determines C. So when I say determine, functionally determines, okay? For example, when I know your ID, say when the university know your registration number, they know your course, right? The university knows what is your course, right? So then the course, when they know the course ID, they know the course name. So therefore, by looking at your registration number, they can determine your course name. Okay, something like that. Okay. So that is transitivity. So union, if A determines B and A determines C, we can say A determines B and C, or B comma C. Right? So then the augmentation, if A determines B, if there's something called C, A and C determines B and C. And projectivity is if A determines B and C, obviously A determines B also, because if the B and C combination is determined A, we can say that the individual element is also determined A. Okay. Okay, so out of those, we will be heavily using the first 2. Okay, first 2. Actually, those are the only 2 that we are going to use. Right, so today we are moving to very interesting topic, closure. Right, remember in your logic subject in maths, we are learning, right, what is argument, and I think we finish it that. Yes, what is argument, what is consistency, and things like that. What is mean by valid argument, that is what is mean by solid others. a sound argument, etc. So, which are the one of the most important thing in your society, in your life, in order to you live a very logical, right, rational life. So this is also a really interesting one, the dependencies, which is close related to the, again, logic, but this is separate topic because this is data thing. So closure, okay, closure. So because in the life also, you have to determine or you have to identify what is the reason for this. Is it because of X that this happened or because of Y it happened? Okay. So a lot of people get confused, right? So I don't know whether they are that stupid or they are doing it, they are just acting like that. We never know. Okay. Right. Right. For example, I will give you a very good example. Right. So before coming to this closure, right? Say someone got corona. Right? Someone got corona. Okay, or someone got, let's say, assume corona is a new one. Someone got, how do you call that? Mosquitoes like dengue. Right? So someone got dengue. Now that person assume that that person got positive, and he has admitted to the hospital, and he got that dengue treatments. You know that they give you, I think, the salines and some other things. Okay, they keep measuring your platelets and the urines and other things, and they keep make sure that your platelets is at the acceptable level. Now, at the same time, assume that so there are some other නේද අපි කියන අත්බෙහෙත් කියලා නේද පැපෝල් ප්‍රතිකාරය කියයි තෙල් කියයි මතුරුපුවා කියයි. So you got that also maybe while you are in the hospital. Now that person go home and say that he says පැපෝල් ප්‍රතිකාරය මරු ඒකෙන් තමයි මට හොඳුනේ කියලා දැන් කියනවා. So now how do you know whether you got it recovered because of that or because of the treatment from the hospital? And there's a third factor as well, because majority of the dengue patients without any treatment also they get recovered. Majority, vast majority. Very few get the fatal, get it into a fatal situation. So more than 95% naturally they recover without anything. Sometimes even the patient don't know. That patient doesn't know that he has dengue. And then the hospital gave you the treatment. Then you have that papillo whatever. Then how do you know the recovery was due to this or that or this? Anyone can tell me how do you determine? How do you come to that kind of a conclusion in a scientific method? විද්‍යාත්මක ක්‍රමයට කොහොමද මේක කරන්නේ? විද්‍යාව ඉගෙන ගත්ත ඇති නේද? විද්‍යාව ඉගෙන ගත්තට නැහැ විද්‍යාත්මක ක්‍රමය දන්නේ නැත්නම් මොන කාලකන්නිකමක්ද නේද? විද්‍යාව ඉගෙන ගත්ත කියන්නේ මේ හයිඩ්‍රජන් ඔක්සිජන් හැදිලා ජලය හැදුනා කියන එකවත් ශාකපත්‍රයේ හරස් කට පාඩම් කරන් ඉන්න එකවත් ගිරවල දාගෙන ඉන්න එක නෙමෙයි. විද්‍යාව කියන්නේ විද්‍යාත්මක ක්‍රමය දන්නවා කියන්නේ. විද්‍යාත්මක ක්‍රමය දන්නේ නැත්නම් විද්‍යාව නෙමෙයි කරලා තියෙන වෙන මොකක් හරි උඩට මොකක්ද කටපාඩම් කරගෙන. Right. So how do you come into conclusions in this kind of a situation? Anyone? So so the experiment, the scientists, what they do is they check these dependencies. They want to double check whether is it because of this or that or combination of this or something else. Right? ඒක තමයි විද්‍යාඥයෝ කරන වැඩේ ඊට පස්සේ. සයන්ටිස්ට්ලා, මයික්‍රෝබයොලොජිස්ට්ලා නේද? ડોක්ටර්ස්ලා, medical practitionersලා. So that is one of their tasks. Okay? Right. Now කොහොමද කරන්නේ අතරම? මෙහෙමද combination එක දුන්නේ කියලා. So you have no rights to go and tell, right? මට මේ පැපොල් ප්‍රතිකාරයෙන් තමයි හොඳ උනේ කියලා. එහෙම කියනවා නම් මහා කාලකන්ණියෙක්. හරි? එහෙම කියන්න බෑ. ඇයි එහෙම කියන්න බැරි? වාට ප්‍රතිකාර තුනක් වාට ප්‍රතිකාර දෙකක් දුන්නා. අනිත් අතට අපි දන්නවා 95ක් නිකම්ම හොඳ වෙනවා කියලා. නිකම්මත් හොඳ වෙනවා නම්. මේ ප්‍රතිකාරයක් දුන්නා නම් මේ ප්‍රතිකාරයක් දුන්නා නම් ඔයා කොහොමද කියලා කියන්නේ? ඔයා තනියෙන් ගිහිල්ලා කියන්නේ කොහොමද? මට මේ පැපොල් ප්‍රතිකාරයෙන් හොඳ වුණා කියලා. එහෙම කියනවා නම් අල්ලන් පොල්ලක් අරන් ගහනවා අපි නම්. ගොන් කතා කියන්නේ එපා. සම්තට්ටුවක් දාන්න. So how do you determine? එහෙම කරනවා නම් මෙච්චරයි කරක් තියෙන්නේ. එතකොට දැන් කාටද කියපුවා මේකෙන් හොඳ වුණාද කියලා කොහොමද කියන්නේ? ඔව් මේකෙන් හොඳ වුණාද කියලා කියන්න පුළුවන්. ඒකට තමයි. So two set of people, we take two set of people, right? So say both of them have dengue, right? So there are dengue people, 100 dengue people, so we subdivide into 50 and 50, and half of them we are not giving any this medicine, this treatment is not given. Of course I don't know how many of you will come in, agree to come into that. Of course there are such kind of people, maybe at the very beginning when these treatments were developing. So we give 50% no treatment, other 50%, now forget about this, we give our treatment, medical treatment. So then we calculate how many percentage of the patients recovered here, how many percentage of the patient recovered here. If this is say 95% recovered without medicine, and say 96-97% recovered with medicine, then we can say that our medicine has some effect. Okay. Medicine has, if both are 95 or this is less, then we can say okay, it is not effective, right? That's as simple as that. So then we know that this particular process has some effect. So that is what the civilized world අපේ වගේ මේ වනචාරී මිනිස්සු නෙමෙයි. අපේ වනචාරී මිනිස්සු ටික තමයි අර පොලිමේ වාඩ හිටගෙන හිටියේ පැණිය ගන්න කියලා. වනචාරී ගොබ්බ මුග්ද හරක් ටික දැන් වෙනකොට වල එහෙම ගිහිල්ලා පොලින් වල ඉන්නවද? බුද්ධිමත් මිනිස්සු නෑ. So first they identified the whatever, I don't know, RNA or whatever pattern. So China published that, right, within 2 or 3 weeks. So they published that, I think that is sort of a DNA or something structure. Then they had already developed in the previous, they had already developed some vaccines, and they knew how to tackle that. So therefore they came up with different people, right? Johnson and Johnson, China, India, and different people came up with their vaccinations. So then once they come up with the vaccination, what they did? After laboratory trial, they take a sample, maybe 10,000, right? 10,000 without vaccine, they just monitor. Other 10,000, they give the vaccine and monitor. And then they test how many people got the disease from those who are given. Actually, not only that, the 10,000 they are giving the vaccine actually. Other 10,000 they are giving a vaccine, but it is not the actual vaccine. It's just a nothing, but they get the injection. Right? Therefore, the patient doesn't know whether they got the vaccine or that the fake one. So then they keep monitoring how many from this sample got the corona, how many from the other sample got the corona, and how many from this sample got died, how many from the other sample got died due to corona. So then they have clear-cut results saying that, okay, how much the effectiveness of this particular vaccine. Right? So that is how they publish. And that is why people all over the world were willing to take that vaccine. Of course, there can be side effects, right? Of course. So we have to take risk in our life, otherwise we can't move on. So that is how you determine whether is it really A determines B. Okay? එහෙම නැත්නම් මේ නිකන් කවුරු හරි කාලි කිව්වයි කියලා ඒ ඇයිලා ගොබ්බ හරක්. හරි තමන්ගේ අම්මා තාත්තුණත් නැන්ද මාමා වුණත් මල්ලියක් වුණත් කියන්න තියෙන්නේ ගොබ්බ හරක් කියලා තමයි. හරි? නැත්නම් එහෙම කොහොමද මේ ගිහිලා කරන්නේ? So with අනිත් රටවල් වල එහෙමත් කරන්න බෑ. එහෙම නේද? ඒ රටවල් දියුණු වෙන්නේ. So now let's see. So that is how you determine whether this is the theory, right? So in natural science, that is how you determine whether A determines B or A not determines B, or whether it's A B combination determines C or whatever. Okay, right. Now let's move on to the concept of closure, right? Right. What is mean by closure? Closure is everything that F functionally determined, right? Everything that F functionally determined is called F closure, and we give this symbol, right? F closure. If it is X, we can say X closure, whatever. It doesn't matter. Okay. So for example, we have a relation or entity with different attributes. Now everything that a particular attribute called AT1 determines is called that attribute 1 closure. Okay, attribute 1 closure, or we can say attribute 1 star. How do you find it? It's very easy. Okay, it's very easy. Now let's take an example. I have a relation or table which has 3 attributes, A, B, and C. 3 attributes. Assume that something like the student ID, first name, last name. Then they have given us some dependencies that they have identified. So they say, this is just example, they say A determines B, B determines C. Now we want to find F closure. F closure means all the closures. F means all. Right? So that means we have to find A closure, we have to find B closure, and we have to find C closure. Okay, so we have to find 3 things. Okay. Right, now let's see. Let's find the A closure. Okay, A closure. So now here you can see that A, by reflexivity, A always determine A. By reflexivity, something is always determined by the same thing. So therefore A determines A. So therefore A is in the A closure. Then it says A determine B. So therefore A determine B also. Then they say B determines C. So therefore by transitivity, if A determine B and B determine C, A determines C also. So therefore A closure is A, B, and C. Okay, A, B, and C. What about the B closure? So by reflexivity, B determines B. Then B determines C. So therefore C is also there, but nothing else. So we can't say that B closure includes A, because it is A determine B, not B determine A. So therefore B closure is B and C. Okay. So then C. Now here you can see that C determines C by reflexivity, but from these 2 dependencies given, we can't determine, we can deduce any other determination, because it is B determines C, not C determine B. And this has nothing to do with C. So therefore we can say that C closure is C. So this is your final answer. Right? A closure, B closure, and C closure. Actually, there's a small printing mistake, or there's a small missing part here. The answer is not there, right? Actually, the answer should be something like this. It should be here. I will update it. Okay, I will update. In the second example, the answer is there. For some reason, for the first example, I have forgotten to at the final example, I have only given you the dependencies. Okay. Right. So let's take another example. Okay. So there are 5 attributes: A, B, C, D, and E. And they have given you 4 functional dependencies: A determine D, D determine B, B determine C, and E determine B. Now you are supposed to find A closure, B closure, C closure, D closure, and E closure. Okay, take 2 minutes and do it. Give it a try. එතකොට කියලා කෝඩින් වල පිටිපස්සේ වාඩිලා හිටගෙන ඉන්න ඕනේ නැහැ. Okay, right. So let's do the A closure. A determines A, and A determines D, and of course D determines B, therefore A determines B, and B determines C, therefore A determines C. Sorry, I got disconnected. So therefore A closure is A, D, B, and C, right? Still we can't say E, okay? Right, what about the B closure? B determine B, right? And B determines C, and that's it. Right, so B closure is BC. What about the C closure? C determines C, and that's it, right? Nothing else. What about the D closure? D determines D, and D determines B, B determines C, so therefore BC also comes. Right? What about the E closure? E determines E by reflexivity, and also E determines B, and also B determines C, so therefore C is also determined. So those are the four closures. Okay. A closure ADBC, correct. B closure BC, C closure C, D closure DBC, E closure EBC. So once you have confidence about the concept, you must have no doubt about it. This is formal science, right? So in the concept that you learn in BIT course, you must have either understood it 100% or you have not understood it. There's nothing called 90% understood. No, in formal science, how can you say that I have 90% understand? So that means you haven't understood it. Okay, this is formal science, maths, computer science, right? Statistics. That is formal science. Okay, so there's nothing called somewhat understood. Right. Now let's look at, now you know what is how to find the closure, right? How to find the closure. So then we have the concept called key, right? Concept called key. So key is, now we know the definition of a primary key, right? Primary key means the selected key that we use to uniquely identify a record that is from the database domain. Okay, but let's make it little bit, not little bit, let's make it a sort of abstract concept. Okay, so this is how you define a key with the help of dependencies and closure. So the key is the minimum set of attributes that fully functionally determine all the attributes. Okay, so then we say it is a key. Okay, it is a key, but it must be minimum. If it is not the minimum, it is a super key. Okay, and there can be multiple minimum keys, and then we have multiple candidate keys. Okay, right, but it's very important that set must fully determine all the attributes, and it must be the minimum. Okay, minimal. Right, now let's see how to do that. Okay, say we have A, B, C, D, E. Now we want to find out, it's a bit of trial and error. Okay, it's a bit of trial and error, and after sometimes you can see, okay, this is the key, or these are the candidate keys. So what you can do is just take one by one first. Say A, we want to find the A closure. Okay, let's have just A. Then write down what are the dependencies of A. Obviously, A depends on A. Then D. Then D determines B, therefore B. B determines C, therefore C. But it doesn't give you the E. Now you can see A, D, A, B, C, D is there. If E is also there, A is a candidate key. but unfortunately E is not there. So therefore still A is not a key. Okay, A is not a key. Now let's add B also. Let's see whether A-B combination is a key. Now B determines C. Of course, B is already there, C is already there. Still it doesn't work. Still E is not there. What about A, B, and C? Now A determine A, those things are there. Additionally, C determines C, and that's it. Still nothing. Still E is not there. Then what about A, B, C, and D? Now additionally D determines B, B anyway there, and nothing else. Still we are not done. So then we have to add D also. Then by reflexivity E determines C. Now we got everything. So therefore, if you go by that approach, my key must be A, B, C, D combination. That means all the fields combination. Okay. Now let's try another possibility. Okay, another possibility. Now you know that until you get E, right? Because E determines B, no one determines E. No one determines E. So therefore, we must take E to the key. And also A is a good guy because when the moment you say A, almost everything other than E is there. So therefore, let's now by doing that exercise, now we have idea that A is a really good candidate, but A is not enough. Actually, we don't need B, C, D because they are not adding any value. What we need is C. Okay, so therefore, let's do something like, let's first do E because you can't get E from anything else. So therefore, we have to use C. And we have to use C. Then, what about if you add A? Then A determines A determines D, D determines B, therefore B is also determined. B determines C, therefore C is also determined. Now you can see that A, B, C, D, E, everything is determined. So that means E-A combination is good enough. If you have A and E or E and A, those two functionally determines all your attributes. And can you find anything smaller than this? That means anything smaller than this is either E alone or A alone. Of course, E alone does not work because E alone will determine only E. A alone will not work because A alone will determine A, B, C, D only. So therefore, there is no smaller value. So this is the minimal. This is the minimal that fully functional determine all the attributes. It is the minimal. So therefore, we can say that we have to select E and A or A and E as the primary key. Now we found the primary key. Right? So the primary key must be A and E. Now you can see we are not looking at employee numbers, so salaries, so department numbers. We are just look at it in abstract level and still we can find the primary key. Right? So that is one of the very important aspect. Right? You understand things at abstract level. Okay, understand things at abstract level. Okay. So if you have any doubts, you need to ask. Okay. Right. So we'll do a past paper question. We'll do a past paper question. Okay, so exam එක දෙන්න හරි මේ චූටි කුකු ප්‍රශ්න දෙන්න ආ හරි එහෙම නිකන් මේ නලව වැඩක් නැහැ නේ. Right. So the question relation බයෙන්නවා මේක දැක්ක කියලා හරි A B C D E with the following dependencies to answer the question 9 and 10. Which of the following can be super keys of the relation? It was which of the following can be taken as candidate keys of the relation. Tackle කරන්න. වැඩි දෙනවා නම් දැන් කරන්න ඕන. So the 2020 paper. So you can download the paper from your BLE, or I think our Google Classroom also be having. If not, your BLE is having. And do it quickly. First to the 9th one. The question is not asking about primary key or candidate key. It's our super keys. Now you must know what is super keys. We discussed what is super keys in the, I think, the second day when we doing the design. So super key is your primary key plus something additional, but it must include your key or your candidate key. But super key means something else as well. But sometimes without something else also you can say super key. But usually super key means your key plus something else. But it must include your key, candidate key. Okay, so let's check it. Right, so we have to start with the given things. So we have to do a little bit of trial and error. Right, so AB determines C, D, and E, F. Right, so now we have C, D, E, F, C, D, E, F. Now we need AB also. Right. Sorry, A determines A. Sorry, AB anyway determines AB. Okay, AB anyway determines AB. So therefore we are done, right? AB determines AB because by reflexivity. And also now it says AB determines C, D, E, F. So therefore AB determines A, B, C, D, E, F. So therefore I will say AB. Right? If AB is there, I will take any other answer as well because they are talking about super keys. Right? Super keys. So therefore now A, B, and D is there. I will take D also. Now you have to check whether CD is going to work. Let's take CD. Of course, CD determines CD. And CD determines A, B, E, F. So that means A, B, C, D, E, F. I will go for CD also. Okay. What about CB? CB determines CB, reflexivity. Then CB determines DF. Now we have the CBDF. And DB determines ABC. Right? ABCE. Now that means A is there, right? And E is there. So it looks like CB is also correct, right? CB is also correct. Because CB determines CB, then CB determines DF, then DF determines ABC. So it looks like C is also answer for me. That is straight. What about E? DEF. DEF. Of course, DEF determines DEF. And DEF determines ABC. Oh, that means ABC, DEF, right? Everything is there, right? It looks like everything is answered. Okay, let's look at the primary key also. It must make a So then they ask which of the following can be taken as candidate keys of the relation R. Now, what is the minimum here? Because this is not a minimum. This is not a minimum. So I will take A, B, and C. A, B, C, D, and C, B. A, B, C, D, and CB. CB is not there. So there I will go for A and B. Okay. Okay. So let's see whether the answer is debatable. I doubt. I wonder whether the answer is debatable because I was not expecting all 4 as answers. Okay. 9 A, B, D, E. 9 A, B, D, E. D, E. Why not C? CB hariyanna. CB determines CB and DE, DF, and DF determine ABC, right? Okay, let's double check the answer also. 9. Penana paper එක කොච්චර ලොකුද කියලා තාම යන්නේ 30 ගණන්. 9 answer is everything other than C. Right? Everything other than C. So 9 everything other than C. 10 everything other than CD. Everything other than. Now, what is the answer? Everything other than C, everything other than CD. 9, 10. Everything other than C. If you make that, everything other than CD. CD. Oh, I can target the no. මගේ උත්තරේ හරි. හැබැයි මට E ආවේ නෑ. මෙතන යා C අරගත්තේ නෑ. ඇයි C ගත්තේ නැද්ද බලන්න. ඇයි මෙතන E ගත්තේ බලන්න ඉස්සෙල්ලා. DF කියනවා යා candidate key. බලමු DF candidate key එකද කියලා. මම check කරේ නැද්ද දන්නේ. Right, so let's take DF. DF. DF determines DF. And DF determine ABCE. ඕනේ. A, B, C, D, E, F. ඕනේ. DF answer එක. Right, DF answer එක. Right, මම DF මෙතන ගත්තේ නැත්නම් උඩ එකේ තියුනේ නැති හන්දා. මම උඩේ විතරක් ඩබල් චෙක් කරේ. Yes, DF is answer, right? යෝ. මේක මට අවුල් නැහැ. එතන උත්තර හරි එතකොට මටයි වැරදුනේ. මම DF ගත්තේ නැහැ. මම උඩ තියෙන ඒවා විතරයි යටේ බැලුවා. කම්බිනේෂන් බැලුවේ නැහැ. Right, මෙතන මොකද දැන් C ආවේ නැත්තේ. බලන්න ආයි C ආවේ නැත්තේ ඇයි කියලා. CB. CB determines CB. CB determines DF. Right? DF determines ABCE. You know, ABCE. That's a document. I don't know why they have not taken C. They have taken other things, but not C. C to yeah. For me, C is answers because CB determines CB, CB determines DF, and DF determines ABCE, ABCE. So therefore, it has determined everything. I don't know. I don't know why they have not taken C. Okay, but clearly for me, everything is answer. But the examiner has not taken C. Here, there is no debate. Answer is ABC. Okay. The method DF ගත්තා නම් ඇයි මෙතන හරි CB බලමු CB නොගන්න මොකක් හරි හේතුවක් තියෙනවද I don't know. I have no idea. Okay. Right. So for me, all 5 are answers, but your examiner says it's only other than C. Okay. Right. So let's look at another question. Maybe some other paper. Right. So there you don't have a direct question. You have a you have only the normalization question. There's a question, right? Right. So do this. Consider the relation R1 PQRST with the following functional dependencies to answer the question 29 and 31. 29 to 31. Okay. So still you can't do the 30 and 31, but you can do the 29. Do the 29th one. Okay, so that is very easy. So PQRST. So you need all four, right? So let's take the first one. Of course, they ask candidate keys. If this is, and if this one or this one is answer, definitely they are not answers because they are the minimal. So therefore, let's first look at the T and R, because if those one of those are answers, definitely these are not answers. Okay, let's look at T. From T alone, you don't get anything because this is RT combination. So therefore, T cannot be. What about R? R determines R. Okay, R. T determine T. Right. R determines R and R determines P. But nothing else, right? Nothing else. So therefore, so this can't be the candidate key. Now let's take this RS. RS determine RS and R determines P, S determine Q. Now we have PQRS, but still T is not there because here we have only R. In order to do that, we have to add T, but T is not there. So therefore, this is not answer. So what about RP? RP, R determines R, P determines P, and of course R determines P, P is already there, and that's it, right? Because here you have to go for RT to get S. So this is not answer. What about RT? RT determines RT, and they say RT determines S, and S determines Q, and R determines P, R is there, so therefore R determines P. So now PQRST is there, so therefore answer is C. 29 answer is C. Anyone got the answer is as C? So ඔගොල්ලෝ question number එකත් එක්ක දාන්න නැත්නම් මම දන්නේ ඔගොල්ලෝ කොයි එකද දැම්ම කියලා. හරි. Right, so the answer must be C, 29. බලමු. Yes, answer is C. Okay, answer is C. මේක ටික ටික ඔළුවට වදින්න ඕන. So let's do one more example and we'll move on to our next topic. Again, question දෙක තාම කරන්න බෑ. Identify the candidate keys. Then pull in on yeah. Then go to okay, right. So let's see. It's very easy. 27E. Okay, let's see whether it's E. Right. Let's look at E. E determines E. And this is EF. So E is not going to work. Then A determines A. And A determines B. And B determines CD. And that's it. Nothing. Not any. So A is not going to work. What about EF? EF determines EF. And EF determines D. Right? And F is there. F determines A. And A determines B. A, B. What about C? B determines CD. Now B is already there. So therefore B determines CD. So therefore C is also there. So EF is our answer. But if you have minimal one, we have to take. Now we have to check with the CD because there can be two answers. If CD is also CD and EF have the same simplicity. But first we have to check with the CD's answer. Let's take CD. CD determines CD. Then nothing, right? So nothing because we need C or D in the left hand side. No. So that's it's a dead. So the answer is C. 27 answer is C. Answer is C. Okay, anyone got the answer C? Yeah, okay. Answer is C. Okay. Right. So I hope you got it. Or if else, or else you have to ask. Okay. So this I told you this is something you must be able to understand 100%. Okay, not just 70%. Right now we are moving to another topic, that is features of good decomposition. And features of good decomposition. I post a separate topic note for that also. Okay, sorry, I didn't see that. Okay. So this one is also for this one as a supplementary note. Actually, I took all the examples from this PDF. Okay, that PDF has a little bit more information, right? So features of good decomposition. Okay, so there are two concepts here to check whether it's a good decomposition. Good decomposition means we have a table. We are going to subdivide it into maybe 2 or 3 tables. Some fields comes here, some other fields comes here. Or maybe this one is further subdivided. That is called decomposition. So we can check whether is it a good decomposition or bad decomposition. Okay. So good decomposition, bad decomposition. So we can say that it's a good decomposition. Right. If it is lossless and it preserves dependencies, right? It is lossless and it preserves dependencies. In your syllabus, they have mentioned only about the lossless, right? Not the preserved dependencies. So therefore, we will be concentrating only on the lossless dependencies. Okay. Oh, sorry, lossless decomposition. Okay. So that means there are two types of decompositions, that is lossy decomposition and lossless. Lossless can loss එකක් නැහැ. එහෙම තමයි වෙන්න ඕන. loss එකක් නැති වෙන්න ඕන නේද? loss කියන්නේ loss වෙනවා. හරි අපේ data. අපේ තියච්ච සම්බන්ධය. A decomposition is lossless if it is feasible to reconstruct relation F from decomposed tables using joins. Decompose කරපු tables වලින් අපිට අර original එක්කෙනාගේ record ටික ඔක්කොම ambiguity එකක් නැතුව ගන්න පුළුවන් නම් අපි කියනවා lossless කියලා. එහෙම ගන්න බැරි නම් ambiguities තියෙනවා අපිට දැන් sure නැති තත්ත්වයකටපත් වෙනවා නම්. කියන්නේ අපිට දැන් sure නෑ දැන් මේක connect කරාට පස්සේ එන data original data මොකද නැද්ද කියලා. අන්න එතකොට අපි කියනවා lossy කියලා. Okay, so then we say it's a lossy decomposition. So lossy decompositions are bad. And so we can't work with lossy decompositions. So what we need is lossless decomposition. So then someone will ask, why do you want to decompose? Right, so that you will understand when we are doing the normalization. Right, normalization කරනකොට තේරෙයි decompose කරේ නැත්නම් ප්‍රශ්න ඇති වෙනවා. හැබැයි decompose කරාම වෙන ප්‍රශ්න ඇති වෙනවා දැන් lossy වුණොත් එහෙම. decompose කරන්නත් ඕන normalize කරද්දී. හැබැයි decompose කරපෙක ප්‍රශ්න ඇති වෙන්නත් බෑ. So therefore what we need is lossless decomposition. Okay, so there's a theory, right, to check whether a decomposition is a lossless or lossy. Right, so this is an example of a if what will happen if the decomposition is lossy. මට හිමින් කරන්නේ දැන් මොකද මේක ටිකක් තේරුම් ගන්න ඕන. Right, so when do we say that a decomposition is lossy? So this is the two possibilities. Where if this or this happen, we say that the decomposition is lossy. Right? If it results in loss of information when join the decomposed relations. When you join the two or three decomposed relations, if we cannot specifically find the original records, then we say it's lossy. What are the two possible things that can happen? First one, some records cannot be formed. So some records that were there in the original records, now you can't find. You don't get it as a result of the join. So then it's a lossy. Or else, too many records resulting ambiguity. Now there's ambiguity. Okay, so that is another possibility of lossy decomposition. Okay, now assume that this is my original table and this is my table, two tables after decomposition. Now assume that you don't see this, right? You don't see this, right? You don't see this because what you have is the decomposed table. Now can you specifically, right, without any doubts, derive that original records from these two? If it is the case, it's not lossy, it's lossless. That means these two are representing the original one. Okay, now how are you going to connect these two? Nimal Colombo. Okay, now here we have the employee ID 1, project 1, Colombo. Right, so what are the possibilities? You can connect like this, like Nimal Colombo, because Colombo and Colombo is there. Maybe Nimal Colombo project 1. Okay, so that is one possibility. Then Nimal Colombo project 2. Then Amal Colombo project 1, Amal Colombo project 2, and Kamal Candy project 3. How many records we get? 2, another 2, 4, and 5. We get 5 records. Okay, how many records were there in the original one? Only 3. But now you can see that we don't know exactly these 3. What we get is 5 possibilities. Out of that 5 possibilities, how do you know whether which 3 is the correct? because we get these two by decomposing this. But when you combine, we get more records. So that means definitely it is not it is not lossless, it is lossy. So we lost our original records. Loss means either it's not there or too many things are there. Okay. Now then someone will ask, how do you come up with this one? Name එක ගත්තා. Project location එක ගත්තා. So therefore, Nimal Colombo, Amal Colombo, Kamal Candy. It was a project එක ගත්තා. 1 project 1, 2 project 2, 3 project 3 කියලා project එකත් එක්ක මේකත් දැම්ම Colombo Colombo Candy කියලා. හරිනේ කැඩු විදිහන්නේ. හැබැයි කැඩුවට පස්සේ මේක දිහා බලාගෙන මේක ගන්න බෑ. මේ කියන්නේ ඔය විදිහට කඩන්න බෑ. ඔයාට ඕන විදිහට. Right? So these are lossy decomposition, right? Because though it looks okay, definitely if you lost this, now by looking at this, you have no way of generating the original record exactly. Right? There's a lot of fussiness. Okay, so it's impossible actually. So therefore, it's lossy. You can see we have additional records. We call them spurious records. So there are two spurious records. Spurious කියන්නේ ඇත්තටම බොරු records දැන් ඇවිල්ලා තියෙනවා. Original එකේ තිබිච්ච නැති ඒවා. හරි? Bogus, fake records. හරි? So another name is bogus, fake records. Have a technical වචනේ තමයි spurious records. Okay? So therefore the above decomposition is a lossy one. Okay? Right. Then මෙහෙම lossy ද loss දැන් මේක lossless දැන් මේ original data තිබිච්ච හන්දයිද අපි දන්නේ මේක lossy කියලා. Original data තියුණ නැත්නම් අපිට මේක lossy ද lossless ද කියලා අපි දන්නේ නැහැනේ. So therefore we need a systematic way of finding whether a particular decomposition is lossy or lossless. Because as database developers, as database designers, we can't say that it may work, it may not work, sometimes it may work. ඒ වගේ පතෝල උත්තර දෙන්න බෑ engineers කට. විශේෂයෙන්ම IT කරන අයට. එහෙම පතෝල උත්තර දීලා බේරලා යන්න පුළුවන් civil engineers කට. හරි. ඕක තමයි ඉතින් මේ කොන්ක්‍රීට් වැලිනේ වැලි ගඩොල් වලට කොහොමද සමීකරණ හරියන්නේ? ඒක හන්දෝ ඕක තමයි සමානලාට ඕක ඉතින් ඔතනින් පුපුරන්නත් පුළුවන්. නේද? හරි ඔතනින් ඩීප් වෙන්නත් පුළුවන්. ඒක මම කියන්නේ එහෙම කියන එක සාධාරණයි කියන එක නෙමෙයි. හරි. නමුත් ඉතින් එහෙම තමයි. Because they are working with natural science. Right? Symmetrical වැලිත් එක්ක ඒගොල්ලෝ වැඩ කරන්නේ. Physics. But this is formal science, so we can't say like that. So therefore, we must have a specific way to check whether is it lossy or lossless. If it is lossless, we can say no worries. This is perfect. If it is lossy, we can say okay, this is troublesome. Don't do this. Don't break like that. Okay. Right. Now let's see. ඔන්න බලන්න කරන විදිය. පොඩ්ඩක් දිගයි. Right. Determine whether composition is lossless or lossy. Consider the relation R decomposed into subrelations R1 and R2. Assume that we had a relation called R1. Sorry, R. Relation and table. And we have decomposed it to two relations R1 and R2 as you. Okay. Right. Then, if all the following conditions satisfy, then the decomposition is lossless. There are three conditions: condition 1, condition 2, condition 3. If all three conditions that we are going to mention below are satisfied, we say that the decomposition is lossless. If any of the condition fail out of these three, then we say the relation is, or the decomposition is lossy. Right? Lossy. Okay. What are these three conditions? Condition 1. Union of both the subrelations, that is R1 and R2, must contain all the attributes that are present in the original relation R. In other words, your R1 union R2 must be R. Okay, R1 union R2 must be R. Nothing less, nothing more. Okay, that is your condition number one. මෙයාගේ තියෙන attributes ටිකයි මෙයාගේ තියෙන attributes ටික union ගත්තම ඔයාලට අනිවාර්යෙන් මෙයාගේ තියෙන attributes ටික එනවා. ඒක වෙලාව විතරක් මදි. ඒක තමයි අපි පළවෙනි condition එක. Second condition. So once this, not only this has to be satisfied, the second one must also be satisfied. So second condition says R1 intersection R2 is not equal to 5. So that means there must be at least one attribute which is common in both R1 and R2. Right? So that is why we say R1 මෙයාගේ තියච්ච attributes තියෙනවනේ මෙයාගේ තියච්ච attributes ගන්න ඔය අතර එක්කෙනෙක් හරි ඉන්න ඕන common attribute එක මේ දෙකෙන්. So that is what it says. Right? දැන් මේක seriously බලන්න කෙනෙක්ට මේ වෙනකන් database එක වැඩ කරපු කෙනෙක්ට ඇත්තට මේක බලද්දිම දෙන්න ඔව් එහෙම වෙන්න ඕන තමයි කියලා. ඔව් ඒක එහෙම වෙන්න ඕන තමයි කියලා තේරෙන්න ඕන. දැන් බලන්න ඒවා එහෙම තේරෙනවා නම් මරු. Okay? තේරෙනවා නම් මරු. ඊට පස්සේ ඒක එක්ස්ප්ලেইন කරගන්න පුළුවන් නම් මරේ මරු. ඒ කියන්නේ ඔයාලට ඔලු ලොජික් තින්කින් උත් වැඩ කමියුනිකේෂන් උත් වැඩ. බයත් නැහැ. ණයත් නැහැ බයත් නැහැ නේ. බයත් නැහැ. ආත්ම ශක්තියකුත් තියෙනවා බය නැතු කට ඇරලා කියන්න. So why do we say that R1 union R2 must be R? බලන්න එක්කෙනෙක් ඉන්නවද කට ඇරලා කතා කරලා පුළුවන්. So the first condition says R1 union R2. The fields in R1 and fields in R2, if you take the union, it must be R. Then කියන්න තරම් දෙයක්ද ඕකේදී obvious නේ කියලා. ඒ obvious නක් කියන්න ඕන. Obvious දෙයක් කියාගන්න බෑ නමුන ජීවිතයක්ද? Anyone? So this is very obvious one, right? So if you have set of fields here, if you have set of fields here, if you take those fields together, obviously it must have all the fields here. Otherwise, how can you say that it is a decomposition of that? When you union these two, if there's an additional field, that is wrong. Because that means you have added a field which was not in the original field. Right? And also if at least one of the field is missing. Now here we had a field called X, but in the union you don't have that. Then that field you have vanished. So it can't be the case. You cannot have anything more, you cannot have anything less. Right? When you do the union, all the record fields must be fields that were in the original relation must be in the two relations, and nothing more, nothing less. Right? So that is common sense. Common sense කියලා මම explain කරන්න ඕන කොහොමද මේ common sense උනේ කියලා. Okay? Can someone explain the second one? So it's more interesting one. Anyone? Why R1 intersection R2 must not be 5? ඒ කියන්නේ intersection එක එක field එකක් හරි තියෙන්න ඕනේ. common එක කියන්නේ. ඒ කියන්නේ මේ දෙකේම common එක field එකක් හරි තියෙනවා. Data will be lost. Yes. Data means fields. Either data is lost or there are something mysterious data which coming from nowhere. What about the second one? දැන් මේ තේරුම් ගන්න නැතුව නිකන් කටපාඩම් ගන්න පුළුවන්. එතකොට ඒක ජීවිතේට එකතු කරගන්නේ කාලා කන්නකම. තේරෙන්නේ නැති දේවල් කටපාඩම් කරනවා. හරි. ඒක තමයි මිනිසෙට වෙන්න පුළුවන් ලොකුම බින්නැහිය. ඛේද වාචකේ. නොතේරෙන දේවල් කටපාඩම් කරනවා. තේරෙන දේවල් දැනුම හැකියාව එකතු කරගන්නවා කියන්නේ එයාට වෙන්න පුළුවන් හොඳම දේ. එයා එන්න දක්ෂයි. එයා එන්න confident. අනිත් කට්ටිය එන්න මන්ද වෙනවනේ. ඒ තේරෙන්නේ නැති මකුල් එකතු කරගන්න. Anyone, why the second rule says R1 intersection R2 must not be 5? Data arrangement. What do you mean by data arrangement? So in order to answer this, you must know a little bit about SQL. Okay. I think you know the answer maybe, right? Right? So when you are retrieving the data, right, there must be at least one common field so that we can relate those two tables and take. So if you relate only, we can say that these fields are coming from here and the rest of the fields coming from here. So then only we can relate these two fields to a same record. So in order to relate, we need to have common field. Right? Without a common field, you can't relate. Right? Without a common field, so that common field is basically your foreign key. Okay, your foreign key. So you need a foreign key to relate those two tables so that you can get set of fields from here, other set of fields from here. Okay. Right. So that is the second condition. Now you can see what condition makes sense. And third one is a little bit more interesting. That is final condition. Intersection of both the subrelations must be a super key of at least one of R1 or R2 or both. Again, intersection. Earlier it says intersection must not be 5. Now it says the intersection of R and R, there is a common field or fields, must be a super key of R1 or R2 or both. Okay. Hari the okay on both දෙනවා කියලා දන්නවද නේද? Now වැඩියත් හොඳ තමයි or both කියලා කියලා තියෙන්නේ. හරි. Super key of R1 or super key of R2 or super key of both. ඒ කියන්නේ මේ common field එක අනිවාර්යෙන් foreign key එකක් වෙන්න ඕන කියලා මේ කියන්නේ. ඉතින් super key of R1 කියන්නේ ඒකනේ. අර යාගේ key එකක් වෙන්න ඕන. key of R1 කියවනම් මොකද්ද? මේ මෙතන ඉන්න කෙනා අර යාගේ foreign keys වෙනවා. නම් foreign key එකක් කියලා තව මේක තව අමතර field එකක් තුලත් කමක් නැහැ කියලා කියන්නේ. ඒකයි super key එකක් කියලා කියන්නේ. හරි. ඔය කියන්නේ කෙලින්ම ඉස්සෙල්ලම කියන්නේ foreign key එකක් වෙන්න ඕන කියලා. foreign key එකක් නෙමෙයි නම් මේ වැඩි කරන්න බෑ, join කරන්න බෑ. ඊට අමතරව field එකක් තුනක් කමක් නැහැ. field එකක් දෙන්න. හරි. right. ඔන්න ඔය තුන බලන්න ඕන. හරි. whether R1 union R2 is R, nothing less, nothing more. R1 intersection R2 is not equal to 5. R1 intersection R2 is a super key of R1 or R2 or both. දැන් අපි කරමු උදාහරණයක්. Right, so these are the example taken from the note I published to you. This one, exact same 3 examples. Right, consider the relation schema R, which has 4 fields A, B, C, D, or 4 attributes A, B, C, D. Right, so there are 4 attributes A, B, C, D in R. Right. With the functional dependencies, A determines B and C determines D. Determine whether the decomposition of R into decompose R1, which has A and B, and R2 relation, which has C and D. ඔන්න කඩලා. මේක දැන් බලපු ගමම පේනවා මේක හරියන්නේ නැහැ කියන්නේ. එහෙන් බලුවම කියන්න පුළුවන් දැන් නම්. ඇයි? intersection එක 5 නෙමෙයි. intersection එක 5. There are no if you take here and here, nothing new, nothing common. So therefore definitely R1 intersection R2 is 5. So it can't be 5. 5 ना can වේදනාවද relate කරගන්න බෑ. කෙරුවට මොකෝ. So this condition is not satisfied. It says cannot be 5, but what we got is 5. First condition is satisfied, right? R1 union R2 must be R, right? Yes. R1 union R2 has A, B, C, D, and of course your R is A, B, C, D. So therefore, first condition satisfied, but the second condition is not satisfied because your intersection is 5. But second condition says intersection must not be 5. That is common sense. Then relate karaganga. So therefore, this decomposition is wrong. It's lossy. I making මෙයාව හදාගන්න කිසිම ක්‍රමයක් නැත. ඒ කියන්නේ මෙතන තියෙනවා ID date of birth, මෙතන තියෙනවා email, සහ contact number. දැන් කොහොමද මේ දෙන්නා relate කරගන්නේ? ඒක තේරෙනවද නේද? ID එකයි date of birth තියෙනවා මේ table එකේ, අනිත් එකේ තියෙනවා email එකයි contact number එක. දැන් ඉතින් කොහොමද relate කරගන්නේ? හරි. මේ මහා ලොකු දේවල් නෙමෙයි යා. පොඩි කොල්ලෙක් කෙල්ලෙකුට තේරෙන්න ඕනේ මේ ඔය ඉතින් ඔබ relate කරගන්න බෑනේ කියලා. ඉතින් ඒවට තමයි ලස්සන formalize කරලා rules දාලා තියෙන්නේ. right. අද ඔයගොල්ලෝ දෙවෙනි එක ඔයගොල්ලෝ කරන්න ඕන. You have to do this. So this is a question. Consider the relation R, which has 4 fields A, B, C, D, with the following functional dependencies: A determine B, B determine C, C determine D, D determine B. Determine whether the decomposition R into R1, AB, R2, BC, and R3, BD is lossless or lossy. හරි ඒක තුනකට කඩන එකක් අන්න මම කරන්නම්. ඒ තුනකට කඩන්නේ අපි කරේ නැහැ තාම. ඔන්න ඒක තුනකට කඩලා තියෙනවා. Right? It's not subdivided into 2 relations. It is subdivided into 3 relations. Right? මෙතන චූටි වැඩක් කරන්න තියෙනවා සපොට්. ඒක explain කරන්නත් එක තමයි question එක දාලා තියෙන්නේ. Right. So now these rules are related to 2 decomposition of 2 sub relations, but here we have decomposition into 3 sub relations. So therefore first thing is you want to subdivide this into something like this. Then this one subdivide into this. And here මේක ඉස්සර දෙකට කඩලා එන එකක් තමයි ආයෙ දෙකට කඩන්න. හරි? කොහොමද එහෙම දෙකට කඩන්නේ? This is how you do it. Okay? So strategy to solve when you have 3 sub relations. When a given relation is decomposed into more than 2 sub relations, of course, this is such situation. Consider any one of possible ways in which the relation might have been decomposed into those sub relations. First, divide the given relation into 2 sub relations. Then divide the sub relation according to the sub relations given in the question. Sub relation එක ඊට පස්සේ ආයි sub relation වලට බෙදන්න. Sub relation එක sub relation වලට ගන්න. As a thumb rule, or as a rule of thumb, remember any relation can be decomposed only into 2 sub relation at a time. එකපාර කඩන්නේ දෙකයි. හරි දෙකකට කඩලා ඊට පස්සේ තමයි ආයෙ එක දෙකට කඩන්නේ. හරි එකපාර තුනට කඩන්නේ නැහැ. Right, now we have A, B, C, D. And the result has A, B, B, C, and B, D. And A, B, B, C, and B, C. Now what you have to do is, now what we have is A, B, B, C, and B, D. First look at the 3 relations, okay? These are relations on the other bar. A, B, B, C, B, D. Now see which one has common things. Now these 2 has a common field called B. On එක විදියක් decompose කරන්න පුළුවන් වෙනවා. So therefore I will take A, B, and C together. I'm looking at these 2. And B, D separate. Okay. So now we subdivided into A, B, C, D into A, B, C, and B, D. Why I took A, B, C? Because if I look at these 2, the common things are A, B, and C. And other one I took like this. Now it is this one and this one. Now, of course, I have to subdivide this. Right? Now I can clearly see that out of A, B, C, we have A, B, and B, C. Okay. So that is one possible decomposition path. Given that they know that they have told you that A, B, B, C, and B, D were the final results. And now you have to check whether this is lossless separately. If you find that it is lossless, if you find that is lossy, that is the end of it. You have to say it's lossy. But if you find that this is lossless, then you have to separately check whether this is lossless. Then if both are lossless, then we say yes, your subdivision is lossless. Okay, that is the idea. AB මෙහෙම අරගෙන BC BD වෙනම ගන්නක් තියෙනවා. ඒතර AB මෙහෙට එනවා. BC D අනිත් පැත්තට යනවා. හරි. ඊට පස්සේ මෙයාව කඩනවා අපහු BC සහ BD එකට. ඒකත් හරි. BC සහ BD. So that is another possibility of decomposition. අපි දැන් මේ කරපු විදිහට කරමු ඉස්සෙල්ලා. So if you have any doubts, you need to ask, right? තේරෙන්නේ නැහැ, doubts අහගන්නේ නැහැ කියන්නේ ඒක ඔයාගේ ප්‍රශ්නයක් නේ, ඒක මගේ ප්‍රශ්නයක් නෙවෙයි. අපි නම් පොඩි කාලේ ඉඳලා පුරුදු වෙලා තියෙන තේරෙන්නේ නැත්නම් බෙල්ල මිරිකලා හරි අහගන්නවා. තේරෙන්නේ නැතිව ඔළුවට આવත් ඊට පස්සේ එදාට රැට නිින්ද යන්නේ නැහැ. ඇයිද මේ තේරෙන්නේ නැති මොකද ඔළුවට දාගත්තනේ. ඒකන්ද ඉබලෙම ක්ලැරිෆයි කරගන්න. දැන් බලමු මේක lossless කියලා. දැන් හරි ඉස්සෙල්ලා එක පළවෙනි ටොපික් එක බලන්න යා. ABCD is subdivided into ABC and BD. Okay. ABCD is subdivided into ABC and BD. And these are the functional dependencies. Make it as functional dependency. Too many. First, let's see whether union is this. Union is A, B, C, and D, correct, right? Yes, your union is your original one. I'm only looking at this one. So then intersection, it must not be 5. Now you can see that B is there, B is there. Yes, B is common. So therefore, the intersection between A, B, C, and B, D is not 5 because we have common value. So therefore, second condition is also satisfied, right? Because it is B. Right? So B is not 5. Then the third condition says, condition C, both subrelation must be super key of at least one of the two subrelations or both. Okay. So intersection of both the subrelations must be the super key of at least one of the two subrelations or both. In QE. Intersection of both subrelations must be super key of at least one of R1 or R2 or both. The intersection එක R1 ගේ හරි R2 ගේ හරි දෙන්නගෙම හරි super key එකක් වෙන්න ඕන. බලමු වෙනවද කියලාද? So what is our intersection? B. Our intersection is B. B කියන එක්කෙනා ඉන්නව නේද? මෙයාගේ ඉන්නව නේද? ඉන්නවා. මෙයාගේ ඉන්නව නේද? ඉන්නවා. මෙයාගේ තෝරනම් ඉන්නවා. එහෙනම් අවුලක් නැහැ. So yes, it is a super key. Okay. Intersection is a super key. So therefore, that relation is, that part is correct. Okay. Condition so super key intersection B and then B balam B aram balan me ABC wahu wenawada kiyala hari B function determines B reflexivity and B function determines C function determines D function determines B. Anyway, B is already there. So therefore, B functionally determines BCD. Other one BCD can super key again. BCD. Tan ed. Metan tahu inne. Me better hariyanne. Habi deking ekata ne wenno. Ena anith deka බලමු. B determines B determine කියලා අපි BCD නේ. BCD බලන්න super key එකක්ද කියලා මෙයාගේ. ඕනේ BCD. වෙන්නේ BCD BD. එහෙනම් එතන අවුලක්. මෙතන අවුලක් වුණානේ මෙතන අවුලක් නැහැ. එකක වුණොත් ඇතියා එකක වුණොත් ඇති. So therefore now we can see that B closure is BCD, Thus, it is not a super key of the subrelation R dash, so R1, but it is a super key of the relation R3. R3 is super key. Then now we know that this is not lossy, it is lossless. Now we want to look at this. A, B, C become A, B, and B, C. Now you can see that the union is A, B, and C, which is same as this. That is correct. Then intersection must not be 5. Yes, intersection is not 5 because this is B, this is B is there. Then you have to check whether is it super key of that intersection, is it a super key of the at least one of the relations. But B came then B came in what? I N B C in main B C. In a kapata karigi, I have the super key at B C D. I know. So the R2 is satisfying that. So therefore, that part is also. So that part is also. So it's a super key of R2. Therefore, that part is also lossless. So therefore, entire thing is lossless. Right? Entire thing is lossless. So that means that decomposition is valid. Okay. Right. So somewhat complex. Okay. Somewhat complex. Complex doesn't mean that you can't understand. Right? Right. So now we are going to take a break. After the break, we are going to do the normalization. Right. So we'll be starting at 8:45. Okay, so let's continue. Right. So now we are moving to the second part of our topic. So now we are done with the theory part. Now we are moving to the more practical part related to the database designing. Right. Normalization of data. So what is mean by normalization of data? Normalization is the second part of the designing. So the first part is mapping your relations into your entity and its relations into the relations and relationships. We discuss how to map many-to-many relationships. You have to introduce a connecting table, how to map one-to-one, how to map one-to-many, how to map many-to-many, how to map ternary relationships, how to map unary relationships, etc. And also how to map weak entities, right? How to map multi-value attributes. What happens when you have composite attributes? We have discussed those things. Okay. So now that is your first part of the design. So this is the second part of the design, that is normalization. Actually, if you do a really good designing in that first part, usually you don't have to do much of a normalization. Most of the time you don't have to do any normalization. Okay. If you do it in a really serious manner. But there are tricky situations where though you do it in a very properly, still your database or your database design may not be properly normalized. Okay. So then we have to do this second part called norm. Anyway, we always do the normalization. And sometimes you will find that, no, I don't have to do anything. But sometimes you will find that, yes, we have to do certain things. Okay. Depending on the complexities. Right. Now let's see. Let's first see what is meant by normalization. So normalization is reducing or eliminating the redundancy of data. Right? So normalization is, if someone asks what is normalization, it is reducing or eliminating or at least reducing the redundant or duplicate data. Okay. So why we don't like duplication of data? When you have the duplication of data means same data is duplicated in the same table or maybe different tables. Right? So when you have redundancy, of course we need, actually there's a small issue here. It says not need less storage. Okay, why do you, okay, so that is correct. Why do you want to reduce the redundancy? When you reduce the redundancy, we need less storage. Okay, duplicate storage are doing it. And also when you have the less redundancy, it is more consistent, right? So when you have the same data in 2 or 3 places, now the same value, say your email address is in this table and that table. Right? So now if you change your email address, now you have to change here as well as here. Right? So that is, there is a possibility that maybe someone has changed this but not this. Then there's inconsistency. So inconsistency is because your same data is over and over in different places, which is really bad. Okay. And you have already experienced those kind of things, right? Some of you. Now, when, for example, when you apply for the BIT, sometimes your birth certificate has your name in one particular format and your A-level certificate has it in another format. Why this? So what is the issue? So they are keeping your name in 2 different places. Birth certificate they are keeping and A-level certificate they are keeping. If they were referring to the same name, you don't have that issue. Now, the affidavit right? So ideally, your name should have been in one place and everyone must have referred to that. Then, so the issue is because of the redundancy, now there's inconsistency. Okay. Right. And also when you have less redundancy, there's a better integrity. We can relate your data in a very precise manner, okay, without any ambiguity. Right. So now you know why we want to do the normalization. Normalization eliminate or reduce duplicate or redundancy of data, which indirectly reduce the storage and improve the consistency and the integrity. Okay. Right. So how do we do the normalization? So it's a sequential process. Right? Sequential process. Sequential process means you do one after the other. Right? First, you have to check whether it is in 1NF. If not, normalize it to 1NF. If it is not yet normalized, we say it is in 0NF or not normalized form. So if it is in not normalized form, first we have to make it 1NF. You can't straight away do the second NF, third NF. If it is 1NF only, once you do make it 1NF, or if it is already 1NF, then you can make it 2NF. So once it is in 2NF, you can make it 3NF. Once it is in 3NF, you can make it BCNF, or you can go for fourth normal form. Okay, it's a sequential. You can't start with the 3NF and then do the first NF. No, it's a sequential process. Okay, right. So what are the 2 main concepts related to when you do in the normalization? The 2 main concepts are atomicity, which is related to the first normal form, and for the other normal forms, the concept is functional dependency, which we already discussed. Okay, for second normal form, third normal form, fourth, or BCNF, etc., the main concept is functional dependency. But for the check whether the first normal form is achieved, the main concept is the concept called atomicity. Okay. Right. Now let's take one by one. Right. Normalization process. So the first thing is make it check whether it is in first normal form. If not, transfer it to first normal form. Okay. Right. How do we do that? How do you know whether something is in first normal form or not? Or some relation or table is in first normal form or not? It's very easy. You have to check if each and every field is atomic or not. If a field is atomic, if every field is atomic, it is in first normal form. If you find that at least one field is not atomic, now it is not in 1NF, you have to do some changes. Okay. Right. How do you know whether a field is not atomic? Right. Not atomic. Not atomic means it can have multiple values. Right. There's a possibility of getting multiple values. So then it is not atomic. So then you have to make it atomic by doing certain structural changes. Okay, right. So let's take an example. So this is an example. So I have custom ID, first name, last name, contact number. Now you can clearly see that custom ID, you can have only one. You can't say that for a particular person, his custom ID is both 5 and 10. So this is definitely atomic. First name, atomic, right? So person cannot have two first names. Person cannot have two last names. But what about contact number? Okay, a particular student or customer can say, okay, I have two contact numbers. Can you keep both? Because if my Mobitel is not working, just call me my dialog. So that possibility is there. So that possibility is there and you have that field. So that means you have violated one NF for this field because contact number is not atomic. Okay, it's very easy. So there is one possible violation. Now what is the solution? Solution is you have to take that field that violate the first normal form into a separate table. Make one to many. One employee can have many contact numbers, the contact details. So therefore, you have to take this out. Now your table has only custom ID, your customer table has only custom ID, first name and last name. Okay, so you take it out. Now you have to put it there into a separate table. Okay, separate table. Where your customer ID is a foreign key there. Yeah, foreign key can custom ID to connect with not. And also you can have multiple, same customer can have multiple contact numbers. So therefore, same customer can have different contact numbers, right? And therefore don't make it your primary key because primary key cannot be duplicated. So you better go for another key, something like contact ID or something. Now we are done. Now the problem is solved. Now all my attributes are atomic and there's a relationship between now these two tables, one to many. Many side has the foreign key, right? Problem solved. Okay. Now it is less duplicate or no duplication and less redundant. Okay. Redundant means less duplicate. කාටරි කියනවා මේ custom ID එක duplicate වුණා නේද කියලා. ඔව් එහෙම duplicate වුණාට කමන්නේ foreign keys. මෙහෙම කමා දාලා වගේ එහෙම සෙල්ලම් තමයි එන්න බෑ. So non key values duplicate කරන්න තමයි බෑ. Let's take another example where first normal form is violated. Right? Product ID, product name, price, those are fine, but you can see color. So for example, there can be alto, white, black can do 3 color. Right? Black එක ගන්න පුළුවන්, white එක ගන්න පුළුවන්, blue එක ගන්න පුළුවන්. Right? So now you are in trouble because this is not atomic. So therefore what you have to do, you have to put it into a separate table and relate it to this one as a one to many. Now we can see that the product ID is your foreign key. So therefore now these two are related, one to many. So this is another example. Now here the problem is in different format. Same problem is there, but this is the original table. So they have the employee ID, first name, last name, then they have qualification 1, qualification 2 fields. Now someone might say, that is fine, it's atomic now. Because your qualification 1 has only one value, your qualification 2 has the other value. So therefore it is atomic. In reality, this is also not atomic. Right? This is not atomic. Why? Now, this is, you have just transfer the problem into a different problem. Okay. So how do you know there are only 2 qualifications? The maximum will be 2 qualifications. Person might say, I have 5 qualifications. So then what are you going to do? Are you going to have 5 fields like that? Qualification 1, 2, 3, 4, 5. Then maybe very rarely a person is having more than 1 qualification. So then you are wasting a lot of storage. Right? Because very rarely employees have more than 1 or 2 qualifications. But some employees have rarely, say, 6 qualifications. Now you need to have 6 fields. Again, we never know whether a new employee comes with 7 qualifications. So that day we are again in trouble and we have to introduce another column. That is another possible 1NF violation. Okay. එතනත් ප්‍රශ්නෙට වෙන බෙහෙතක් දීලා තියෙන හොර බෙහෙතක් දීලා තාම ප්‍රශ්නේ තියෙනවා. Again you have to separate it into a separate different table. Right. මේ තවත් විදිහකට මේ ප්‍රශ්නේ පේන තරම් කවුරු හරි. Right. So this is a purchase order and these are order items. So they are keeping all the information in the same table. So actually this is something like duplicated. Because for each and every order item, the order details are the same. Here also there's a duplicate. Okay, another duplicate. If you have 5 items, order items, you have 5 duplicate entries, which is really terrible. So this is also violation of atomicity. So again, the solution is take this to a separate table. Okay. And have the purchase order number as the primary key, foreign key. Okay, so I show you different ways 1NF can be violated, and you have to see that this is a 1NF violated. This kind of things, you see something like this, or you see something like this. If 1NF is violated, you have to make sure that you take it to another table. Okay. Right now we are moving to the second normal form, 2NF. So second normal form says relation is in 2NF. If it is in 1NF, obviously, if it is not in 1NF, you don't have to think about 2NF anyway. If it is 1NF and every non-key attribute is dependent on the whole of the key and not on just part of the key. Right? This is more important when you have composite primary keys. For example, I assume that we have a table. Say student table. So we have student ID. Say student name. Okay. So then we have the course ID. Sorry, course fee. Now you can clearly see that your student name depends on your student ID, which is your primary key. But if you take your course name or maybe something else related to courses, it is not related to student ID. So therefore, there's no dependency. It is sort of orphan. So then it is not in 2NF. ඒක fully depends වෙනවා කියලා ඉතින් තියෙනෙත් එකයි කොහෙත්ම depends වෙන්නේ නැත්නම් හරි course name එකයි student ID එකට සම්බන්ධයක් නැහැ නේ student ID student connect වෙනවා course ID එකට course name එකකට නෙමෙයි නැත්නම් course fee එකට නෙමෙයි right so therefore this has violated the 2NF when you have single primary key also then we have composite primary key. It is more interesting. So in composite primary keys, there can be a situation where now composite primary key means here the student ID and the course ID. Now, if you look at the payment, it depends on both or the totality of the composite primary key. Because this payment is from this student for this course, from this student for this course. So therefore, this is fine. So payment field has not violated your second normal form. But what about course name? Course name depends only on course ID. There's nothing to worry about student ID because this is course name. So course name depends on course ID. We can't say course name depends on student ID directly. So therefore now we have partial dependence. So this must not be here. This must not be here because it has violated the second normal form. It's a partial dependency. Not depends on the total primary key. It depends only on the part of it, both sides. Okay. So with some past paper questions, exercises, you will get that. Initially, you will be little bit confused. Right. So now we found that this is wrong. Now the solution is, this is not the place to keep your course name. This is student course table, connecting table. So this should have been in where? Your course table. This is by mistake, you have taken it to the course student table. Okay. Because it is not depending on both or the totality of the primary key. It depends just on the part of it. So therefore, it has violated second norm. Again, the solution is take it to the relevant table. That's it. Right. Now we are moving to the third normal form. The third normal form say we have to look for the third normal form only if it is in first normal form and second normal form. Right? No, every field is atomic. All your fields are fully depends on the primary key. So then only you look for the third normal form. So third normal form says your non-key values must be directly related to primary key, not transitively or indirectly related to another one. Okay, it's very easy. Okay, so in short, no transitive dependencies. Okay, right. So let's take an example. Say I will take a much more small, simple one. Okay, say I have student table. So I have student ID, student name, date of birth, course ID, and course name. Now, what is the primary key? Student ID. Now, the third normal form says your non-key fields must directly depends on the primary key, not indirectly. Right. Now, you can clearly see that name directly depends on the student ID. Date of birth directly depends on the student ID. Even course ID directly depends on the student ID because that is the course done by the student. But if you look at the course name, a course name is not something directly dependent on the student ID. It is depending on the course ID, and course ID depends on the student ID. So this is definitely a transitive dependency. So when you have transitive dependency, the solution is again you have to take that field that violate the third normal form into a relevant place and relate. Okay. Again, you need a little bit of exposure, a little bit of experience to do that. Okay, see whether this one has any issue. So this is purchase order. So the purchase order number is the primary key. Purchase order date is fine. Okay. Do you need employee code? Maybe the employee who entered that purchase order. Supply number. Needed, right? When you are having a purchase order, you must know who is the supplier. Yes. What about supplier name? Supplier name is, now you can see supplier number is depending on the purchase order. But supplier names depends on the supplier number and supplier number depends on the purchase order number. So therefore, it's a transitive dependency. Okay, there's a indirect contact, no direct contact. Okay. Right. So this is another example. So many examples I have given. So we have a book table, book ID, that is your primary key, then the book name, publisher, contact number. Now, obviously, book name depends on the book ID. Publisher depends on the book ID, but contact number is the contact number of the publisher. It's not the contact number of the book. Therefore, this is something like that. So therefore, there's a transitive dependency. Ideally, this field should have been in the, not the book table, it must be in the contact table. Okay. Contact table එකේ දාන්න ඕනේ ගත්තම මෙතනට ගෑවලා දාති. So you have to take this to the contact table or publisher or whatever, and you get rid of that. Okay. So if you want, you can further normalize. Right? So we discussed only up to first normal, second normal, third normal. So then there's something called BCNF, boycott normal form. Then you have the fourth normal form and the fifth normal form. Right? So you must not understand, you must not think too seriously about the BCNF, and we are not discussing the fourth normal and fifth normal form. The simple reason is in day-to-day or even in professional software development, most of the time you don't have to go beyond 3NF. It is more than enough. Okay. But anyway, so therefore we are not going to discuss fourth normal and fifth normal at all. But little bit of understanding about BCNF for the boycott normal form is handy. Okay. So what does BCNF says is, sometimes we call it 3.5 NF also. Right. So let's take a simple example. Of course, you don't have to fully understand this because you will get more confused initially when you look at the BCNF. Okay. Right. Assume that we have a student, course, and instructor. Okay. Now assume that your instructor depends on student and course. Okay. Now, if you have your data like this, there's issue. That is, if you don't have student ID, course ID combination, you can't add an instructor, because you can say for this student, for this course, instructor is Niman. For this student, for the other student, for the same course, this. Maybe for the other student, for the separate course, this. Okay. Now, if you have the instructor in this table, that is not a good thing to do. The reason is, if there's an instructor who is not belonging to any course or not assigned to a student, but instructor is there, now you can't say student ID is null, course ID is 1, and instructor is this. You can't have null value for primary keys. And also you can say student ID is Nimal, but course is null because we don't know, and this is the instruction or whatever. So don't do that. Okay. Because if there's no student, you can't add the instructor. If there's no course, you cannot add the instructor. So therefore, this is bad design. And this is, we say that this has violated the BCNF. Right? If you want to activate BCNF in your table, you have to separate this into a different table. Okay. Now you can see that instructor and student, instructor and course. So once you separate it, yes, that is fine. But it is not a must. Usually you can understand BCNF without much issue as well. Okay. Right, now we are moving to our final topic, denormalization. Don't think too much about BCNF. They have never asked about BCNF. They have only asked about 1NF, 2NF, 3NF, okay? And denormalization. What is denormalization? So that is the opposite of normalization. In normalization, we try to break it for better integrity. In denormalization, we try to break these broken tables, so the two parts of the same table, we try to again combine them to make it a bigger table. So denormalization is not always done. If you do it without purpose, it's a bad thing as well, because normalization is the standard process. But sometimes, very rare, it can be inefficient. In that case, we again combine these into the original table with some precautions. So that is called denormalization, the reverse process of the normalization. So then someone will ask, if normalization is really good, why are you worried about doing the denormalization? So the simple reason is, when you go for normalization, you have to introduce new tables. Right? So when you introduce more and more new tables, so new fields and new tables also, we need more and more joins to retrieve the data. Right? For example, here, when you retrieve the student information together with, let's example. Right, student information together, product information together with the color, right? You are in trouble, right? You are in trouble because you can't relate it. So you are in trouble means you have to combine two tables, because your product details are in this table, color details are in this table. Now, whenever you need product information like its price and color, because different color product may have different prices, as of course in this case it is not the case, but at least you want to know what are the prices available, so what are the colors available. Then you are in trouble. Actually, you are not in trouble, but you have to do a join, which is little bit taking more time. Okay. So in that kind of situation, if you are really concerned about too many joins, you can again take it back to of course, in this kind of situation, we don't recommend you to do that, but there are situations, maybe something like this, where you will keep the course name here itself, though you know that it is violating the second normal form. Right? So though it is violating the second normal form or third normal form, you still keep it to reduce the joins. So that is called denormalization. It is not something we always do. It is not something we recommend. But if you are really worried about performance, when you have thousands and sometimes thousands and thousands of records, sometimes you may decide, okay, I'm going to denormalize and keep that field here, just to increase the efficiency of the queries. Okay, that is called denormalization. Right, so let's do a normalization question as well, maybe one or two past paper questions. Let's see whether there are past paper questions in 2019 related to normalization. Lot of questions from SQL. Okay, so 26. Do this. Just pay attention to the rules in first normal form, second normal form, third normal form. Usually you don't have to see BCNF, but you can just look at the BCNF as well. And you have to check whether What is the normal form this relation is in? Primary keys mark කරගන්න, foreign keys mark කරගන්න, ඊට පස්සේ කල්පනා කරලා බලන්න මේක 1NF violate කළාද? violate කළා නැත්නම් then violate කරනවා එතනින් ඉවරයි 0NF කියලා නවත්තන්න. If it is not violated 1NF, now we have to check whether it has violated 2NF. If it is not, then you can see it's in 1NF. If it is has not violated 2NF, you have to double check 3NF because now you know that it is in 2NF. Remember? What is the best normal form that the employee relation satisfies? එක එක බලන්න ඕන. Employee relation. You can clearly see that this must be your primary keys, right? Employee ID, NIC. These are not the relations, these are dependencies, okay? These are just dependencies. එක relation එකක් තියෙනවා. බලන්න ඉතින් atomic ද කියලා. Employee ID, that is fine. NIC, fine. First name, fine. Last name, fine. Address, fine. Salary, fine. That means it's in 1NF. Atomic නේ? කැලි එකකට වඩා තිබුණා නේ කොහෙවත් නේද? Address දෙකක් එන්න බෑ. Salary ගොඩක් එන්න බෑ. First name පහක් එන්න බෑ. NIC දෙකක් එන්න බෑ. So therefore 0NF එන්න බෑ දැන්. දැන් බලන්න ඕනේ දැන් මේක 1NF. දැන් බලන්න 2NF දෙක. 2NF නම් මොකද වෙන්න ඕනේ? All your non-key values must fully depends on the primary key. මෙතන composite primary key එකකුත් නෑ වගේ. ඒකන්ත බලන්න depend වෙන්නේ නැතිව තියෙනවද කියලා නැත්නම් partial dependency වෙනවා තියෙනවද කියලා නෑ නේද? NIC එක F name, L name, address, salary. So that means it is definitely 2NF. It is not violated. Composite තියෙනකොට තමයි ගොඩක් අය violate වෙන්න බලන්නේ. Composite නැත්තම් බොහොම කලාතුරකින් තමයි 2NF violate වෙන්නේ. In third NF, we want to check whether are there any transitive dependencies. අවුලක් වෙනවද නෑ නේද? NIC depends on employee ID. F name depends on employee ID. L name depends on F. Directly යනවා නේද? Address මෙයත් එක්ක. මේවත් අතර සම්බන්ධ නැහැ. Salary මෙයත් එක්ක. එයා 3NF උත් ඉන්නවයි කියන්නේ. Third normal form උත් ඉන්නවා. right? Transitive dependencies තියුනේ. What about fourth normal form? ඇත්තට මෙයාට fourth normal නෙමෙයි බලන්න sorry fourth normal බලන්න බලන්න BCNF හරි. මෙයාගේ BCNF violate වෙච්ච බවකුත් පේන්නේ නැහැ. මොකද මෙතනට ඒ වගේ අර composite P ඇවිල්ලා පහුතපට වෙලත් නැහැ. right? So therefore should we go for 3NF for BCNF? BCNF තියෙනවා අපිට ඕන ඒකට දාන්න පුළුවන්. හරි. මම දන්නේ examiner දෙකම ගන්න ඉතින් සාමාන්‍ය එකයි ගන්නෙ අගම එක. So therefore I will go for BCNF. Okay. මෙතන risk එකක් තියෙනවා නම් ඔයාලට ඕන දෙකටම ගහන්න පුළුවන්. මොකද ගියොත් 4න් එකයි ආවොත් ගොඩක් එනවා. නැත්තම් මේ ගොඩක් හරි ආවොත් භාගයයිනේ. උත්තර දෙකක් තියෙනවනේ. හැබැයි ගියොත් යනවා 4න්. හරි. බලමු උත්තරය හරිද කියලා 26 BCNF ද නැත්නම් ඒගොල්ලෝ අරන් තින්නේ D දන්නේ නැහැ. මම හිතනවා E කියලා. 26. C අරන් තින්නේ. 2NF C ගත්තේ කොහොමද? දැන් third normal form එක violate කරලා තියෙනවද කියලා? third normal form එක violate කරලා තියෙනවද? බලන්න මෙන්න මේ වෙනුත් බලන්න ඕන. Employee ID determines NIC, first name, last name, address, salary. That is fine. Then they say NIC determines first name, last name, and address. එහෙම උනා කියලා ප්‍රශ්නයක් නැහැ නේ. පොඩි මේ තුන් දෙනා මෙතන තියෙනවානේ NIC ඉන්නවා. and then I see enough first name last name address salary හරි මට නම් තේරෙන්නේ නැහැ ඒක නම් අයියා ගත්තේ කියලා මේක හරි මට නම් ඕක ඔක්කොම ටික වයලට් කළා නෑ කෙනෙක්ව 3NF හරි BCNF හරි කියලා දැන් මම ගන්න යා කියන 3NF නැහැ කියලා මට නම් 3NF වයලට් වෙච්ච තරක් පේන්නේ නැහැ ආයෙ බලන්න ඒක වයලට් වෙලාද කියලා මට නම් පේන්නේ නැහැ හරි I don't see I don't agree with that answer okay make consider the relation inventory with part number, warehouse, location, quantity, weight, color with the following dependencies. Which of the following statement is are correct? Just a one table and you have composite primary key. Composite primary key part number, warehouse number. This is atomic deal. Part number is there, warehouse is there, location. Right? For this part number, for this warehouse, atomic diameter quantity atomic, weight atomic, color ගැන යා කියලා නැහැ හැබැයි නේද අපි හිතමු color එකයි එන්නේ කියලා එයා කියලා නැහැනේ කියලා නැතිව අපිට ගන්නත් බෑ so let's give the benefits to the user and we'll say okay this is fine 1NF is okay now we have to check whether 2NF on a composite primary key එකක් තියෙනවා හොඳට පරිස්සම් වෙන්න ඕන location has no connection with the part number location is something to do with the warehouse only yeah. So therefore the location depends on warehouse so therefore it is not in 2NF because there are partial dependencies so therefore what we can say is it looks like it's atomic so therefore I will say are they asking separately right functional dependency one violate no what they say is which functional dependency violate which one okay right part number determines weight and color part number part number weight එකයි color එකයි determine වෙනවා ඒක warehouse එක මත depends වෙන්නේ නැහැ නේ එහෙනම් අනිවාර්යයෙන් මෙයා second normal නෙමෙයි it violates second normal so this violates second normal because part number is just part of the primary key it has determined weight and color part එකක් මත depends වෙන්න බෑ so therefore it is not 2NF so therefore A is answer it violates 2NF what about this part number warehouse determines quantity that is fine because that is total primary key determines quantity this is fine FD2 is fine okay FD2 is fine so that means it has not violated the second normal form so therefore we can say it is in second normal form right third normal form again second normal form FD2 violates 1NF කෙනෙක් කොහොමද වැරදි FD3 violates 3NF warehouse determines location no right so warehouse is just part of the key so therefore it violates the second normal FD3 violates the second normal so not third normal right third normal එක නෙමෙයි violate කරන්නේ the best normal form that inventory satisfies is 1NF ඔව් ඒක හරි මොකද 2NF violate කරලා තියෙනවා දැන් තමයි 2NF violate කරලා තියෙනවා so therefore definitely it is only 1NF so answer is A and D 40 let's first look at the answer yes A and D okay A and D may NIC determine first name or last name indirectly determine? No. Your first name doesn't determine last name, right? No. First name determine can and last name. So therefore you can't say indirectly. It's direct. NIC determine first name, NIC determine last name. Okay. There's no indirect relationship there. Right. Okay. So we'll do few more questions related to the. Now you have to very clear. 1NF says your fields must be atomic. 2NF says your non-key fields must fully depends on the primary key, not part of it. Especially when you have compound primary key, you have to be worried. The third one says, third normal form says, there cannot be any transitive dependencies, right? Your non-key attributes must directly depends on the primary key, not indirectly through another field, okay? Right, so now we have done 4 topics, okay? 4 topics. So we have only we have 3 more topics. That is relational algebra, then SQL. SQL is a big topic, and the security. Okay, right. So, okay, we'll stop at this point. Okay, right. So next time, most probably we will be doing again maths. If we want to finish maths very quickly. Okay, right. We'll stop at this point.